Hey guys, welcome back everybody. So we have covered the lots of the thing in spanning tree protocol, right? So today we are going to discuss about like how you can protect the spanning tree network. That's called as a spanning tree security, right? Or you can call as a spanning tree protection. So basically, you know what happened. Let me tell you. Let me give you one example. So let's have a look, guys. Please be on mute, right? Let's take an example. We have a switch one, right? And this switch one has connected with the switch two right now, and this switch two has a connected with the switch three, right? So this is my stable topology right now because this is my root bridge, and this is my 0/0. This is my 0/0 1. This is my 0/0. This is my 0/1 again. This is my 0/0. And this is my 0/1, right? So right now, what we can call this guy? This is my DP port. This is my DP port. This is my root bridge. This is my RP, and this is my RP. And again, what happened? We have a DP and we have a blocking port over there, right? So this is called what? This is called as a stable topology. This is called as a what? Stable topology. But take example, what happened? If any attacker, right? If any attacker will join this network, right? For example, I have this is the PC that is connected to this guy, and I will have another PC over there. So it's three, right? This is the 0/2 interface. This is 0/2 interface, right? So normally, if you guys remember that on every interface, right? On every interface, doesn't matter is a access port, right? Or trunk port. On all the interfaces, we have enabled the spanning tree protocol, right? By default, on all the interfaces, spanning tree protocol is enabled. It means that from this particular interface, I can send the BPDU packet, right? And from this interface, I can send the BPDU packet. So try to understand, if I'm sending the BPDU packet from the trunk interface, that's fine, right? Even take example, if I'm sending the BPDU packet from this interface 0/0, as well as this is fine. But what happened, right? If this attacker comes in the picture, right? The attacker over here, what they will do that they will bring on PC over there, and they will remove this PC from this port, and they will just connect this PC to this port now. This is the attacker. What this guy is gonna do that? This guy is gonna just generate the one BPDU packet to this particular interface. If this guy is gonna generate the BPDU packet in this particular interface, then what he will do that? He has a lots of things to do, right? He can change the priority of the own switch. He can say that let's make a priority of 0 this interface. Sorry, this priority of 0 this switch. Then what happened? This guy will become the root bridge, and this guy will go in the non-root bridge. Then what happened? Your stable topology will move in the non-stable topology, or we can say the unstable topology. So basically, what's happening, right? If the attacker will join your network, they can do anything with your network, right? So if they join to the access port, and if they will generate the BPDU packet, they can make a request to everyone, hey, my priority is a 0, so I would like to become the root bridge. So you cannot do anything over there because in BPDU packet, right, itself in the BPDU packet, there is no any kind of password filled over there. If you guys remember that, we have a password in the BTP protocol, but there is no password in the BPDU packet. How we can prevent this thing? So to avoid this problem, right, to avoid this problem, what we have to introduce, we have introduced the spanning tree protection, or we can say the spanning tree security. So we have a different security in the spanning tree protocol. The first security that we are going to talk about, that's we are going to talk about the access interface perspective, right? Access port perspective. So take example how we can put the security in the access port. So let's have a look, right? Let me remove this guy again. And I have a 0/2 now. Let me put the port again back, the PC we have, and 0/2. So normally, if you guys remember that yesterday, we have discussed the concept about the TC and BPU, right? So normally when your port is going to blocking to the forwarding, right? Or forwarding to the blocking. So normally in that case, what happened? So the switches is going to generate the TC and BPU. The TC and BPD has our own advantage and disadvantage too. The TC and BPD is just gonna, the major advantage if I talk about the TC and BPD is what? It's just gonna tell to the root bridge, hey, something had changed in my network. And what root bridge will do that? They will just send the configuration BPD. In that configuration BPD, they will just on the TC flag, and based on the TC flag, all the non-root bridge switch, will reduce the MAC address aging time 300 seconds to the 15 second, which is known as a forward delay timer. And that's a best thing about it, right? That's a use case of the TCN BPDU. Now, at the same time, if you see this interface can, like if this interface goes down and up, for example, if I'm gonna shut down this PC and if I'm gonna turn on the PC again, then what happened in the both the cases, right? This interface will generate the TCN BPDU, right? And this is called as a insignificant topology change. Yesterday we have seen that. There will be no impact, right? There will be no impact in the topology, but only the thing is what? The convergence time will be changed over there. So to avoid this problem, what we can do that we can enable the port fast on this particular interface, right? With the help of port fast, what we can do that if this interface goes down and up, I will never generate the TCN BPDU. Another benefit of the port fast is what? In this interface will immediately move in the forwarding state and it will just skip the listening and learning. That's we have seen that yesterday, right? Now try to understand. Focus on this point. If this guy is directly moved to the forwarding state or it will skip the listening and learning, then what happened? If the attacker comes in the picture over there, right, and they bring their own PC and they will connect this PC to this particular port, then what happened? They will remove this PC first of all, right? And they will connect this PC to this port. Now he can generate the BPDU. If this guy is going to generate the BPDU, then what happened? There will be a temporary loops. At the same time, one is the temporary loop. Second thing is what? Now, after generating the BPDU packet on this particular interface, now this attacker can inform everybody, hey, you know, one thing, my priority is a 0. So I will behave like a root bridge as well. So they can make an attack in my network as well, right? So to avoid this problem, what we can do that over there, because he will generate the BPDU packet. So I will put the one guard over there, right? I will put the one guard and this guard name is called as a BPDU guard. What this BPDU guard is going to do that? It seems like a gatekeeper in your society, right? So whenever you are entering in the society, the gatekeeper will stop you. They will ask you a few questions. Where do you want to go that? Okay, if the owner will approve the request, right, then you can join then you can enter the society, right? Same thing is that the BPDU guard. What I can do that I will apply this BPDU guard on this particular interface. Now, what this BPDU guard is going to do that? If somehow, if I'm going to receive the any BPDU packet on this particular interface from the attacker side, right? If I'm receiving any BPDU packet on this particular interface, what I will do that immediately I'm going to block this interface. Immediately I'm going to block this interface, and that block the interface is known as a error disable. So immediately what happened? Your interface will move in the error disable state. So in this error disable state, what happened? Neither you can send the data traffic, neither you can send the BPDU packet. It's same like that, right? If you're going to compare with the error disable, it's same like that. It's a shutdown port. Neither you can send any data traffic. Now I can secure my network with the help of BPDU guard. So what BPDU guard is going to do that? They will put the eye, right? They will put the eagle eye on this particular interface. They will put the eagle eye on this particular interface. They said, hey, if I'm going to receive the BPDU, doesn't matter if the attacker or normal switches, I'm going to block that interface. And that's how we are preventing my spanning tree network. So it is a recommendation to do that whenever you're going to enable the port fast. It is a recommendation to do that enable with the BPDU guard. If you're going to enable with the BPDU guard, then you are protecting your spanning tree network. By default, the BPDU guard feature is disabled. Even the port fast feature is disabled. You need to manually enable this thing. The port fast has its own use case. The port fast is going to directly put the port into the forwarding state instead of waiting for the 30 seconds in the listening and learning, right? And second thing is that port fast is what? If the interface is port fast enabled, they will never generate the TCN BPDU. So once the port fast is enabled, make sure that your BPDU guard also should be enabled over there to just prevent the attack in my spanning tree network, right? So have a look what I can do that. let me show you this behavior. So if you see right now, what I can do that, I'm just gonna connect this interface. So normally if you see that, if I'm gonna connect this guy, it will take the 30 second. Can you see that? It's in the amber state right now, zeros last one, right? It's an amber color. So if you see the CLI of this guy, he will say that the interface is in the listening state. Can you see that? So it will take the 30 second learning now. It will spend the 15 second in the learning state. And still you can see that's amber right now, amber color. It will take the 30 second to put this port into the forwarding state. That's a bad thing. Yesterday we have seen that now it's forwarding state. It's green now. It means that now I can send my data traffic. So to avoid this problem, what I can do that I just go under the interface 0/2, right? I say the interface 0/2, and I call this guy a spanning tree port fast done. So now I have just enabled the 0/2 as a port fast. Now if I'm going to connect the cable with the 0/2, what happened? Immediately this interface will move in the forwarding state. So I'm not going to wait for the 30 seconds. Can you see that's now green? So if you see, it's directly in the forwarding state. 0/2. What's a better thing we can do that over there? I need to enable the BP2 guard. So I need to put the guard over. So if you're gonna enable the port fast, it is recommendation to do that, to enable the BP2 guard too, so that if the attacker is trying to attack in your network, they will put this port into the blocking state, or we can call as a error disable state. So interface 0/2, I say the spanning tree BP2 guard enable. So now the BP2 guard is enabled. So what happened? This guy will be sitting over there. And what this guy is going to do that, he will keep tracking the BPDU. So right now, I'm not able to receive any BPDU, right? I'm not receiving because PC doesn't generate the BPDU, because BPDU is what? It's a layer 2 protocol, layer 2 packet, right? So PC never generate the BPDU. So if the PC never generate the BPDU, my interface is working fine. But somehow, right, take example, right? I'll just connect the one switch over there. I'll just gonna remove this guy. 1 minute. If I'm going to connect the switch 2 right now, have a look. What happened? The switch 2 will generate the BPDU packet. Wait for some time. Can you see that? It's going the error disable state. Once the switch 2 has up this interface, they will send the BPDU packet. Already BPDU guard is present over there. They will detect the BPDU. If they will detect the BPDU, I will put this port into the error disable state. So can you see that on the interface 0/2 is up right now? Previously, it was a PC connected. So PC never generated the BPDU. It was working fine. But once I connect the switch over there, what happened? Switch 2 has generated the BPDU. And once the switch 2 will generate the BPDU, right? Switch 1 will receive on this particular interface. On this particular interface, the BPDU guard is enabled. And I will put this port into the error disable state. Error disable state is something like that. Your spanning tree is not their kind of disable state. So maybe you have a question, hey, I can do the shutdown. So to remove the error disable, what you can do that, you can just put the shut and no shut command. The interface will be working fine. But again, what happened? If I'm going to make a shutdown, no shutdown, have a look. Interface 0/2, set the shutdown. And I said the no shutdown. Can you see that? It's green now. Wait for some time. It's again going the blocking. The reason is that again, he generated the BPDU. He will receive it. And there is a BPDU guard is enabled. He will again put the port in the blocking state. So that's one way that you can prevent the what my spanning tree network with the help of BPDU guard. By default, BPDU guard is disabled. You need to manually enable it. it is a recommendation to do that, right? It is recommended to enable port fast with VPD guard, right? Another way we have, right, in this BPD card, what happened? Normally in this BPD card, what happened? Whenever the switch receive the BPD card, whenever the switch receive BPD on the BPD guard interface, they will put that particular port into error disable state, or we can simply call it as a disable state, right? To just prevent the loop, prevent temporary loops, and my network, STP network from the attack. So that's one way that you can use the BPD guard features in your network. So you can enable the BPD guard on a per interface basis and enable the BPD guard on a per interface basis and global configuration basis as well. So per interface means what? You just need to go under the interface and you just need to put the command spanning tree BPD guard enable, right? You just need to go this interface and just see that interface 0/2, 0/0. It's not been copied. Let me copy it. Copy, and that's all. And if you want to enable the global configuration, what you can do that? I just put the command. Let me show you the command in the VMware because I don't think the Cisco packet tracer does support the global configuration. Let me check it. Spanning tree, BPD guard, it's not supporting it. Let me open our VMware. So see, I'll tell you one thing about the BPD guard. So most of the people were thinking about the BPD guard. So you can apply on the interface and just prevent the temporary breathing loops, right? Just prevent the temporal. That's how the even the books are written over there. But it's up to you to think about the network, right? Take example, if I'm not going to enable the BPD guard, what happened? Okay, the temporary loop will be there, that's fine. But apart from this thing, what? Apart from your network will be not secure, right? This part also will be not there. Your network will be not secure to just prevent the temporary loops and my STP network from the attacker. So two things will be happen. One thing is that's a book written like this, temporary loops. But second thing you need to think about it. I have to prevent the attack from my attacker, right? So that attacker cannot join the STP network and they cannot manipulate anything in my STP network. Because if the attacker, right, will change the priority, they're like if they are able to generate the BPD, they can change the priority as well. So your complete stable topology will move to the unstable one. So can you imagine, just imagine now, if your stable topology is going to move to the unstable, then what happened? All the network traffic will be changed the path. So if the attacker has a, right, if the attacker can handle your layer 2 network, they can do anything with your network now. They can do anything with your network. So that's a very, very important task. What if you want to enable the port fast, make sure that your BPD guard is enabled. Let me show you this command, the default global configuration mode 1. And I'll do that switching. I think so. I need to check the this as Oh, wow. Sorry, mine. Okay. Anything is fine, right? I'll just take the STP one, uplink first, and let me wipe this configuration, right? And let's turn in this device. Now let's go to the switch one, switch two, and switch three. So no, yes, yes, no, yes, yes, no, yes, yes. How about the spank right now? So it's something. Oh man. Okay. So now you can see the command for the spine tree. We will guard command spine tree code fast. H BPD guard. So that's all default. So this is the default command to the for the global config. This command is not going to work for the Cisco packet or something. So if you see the spine tree, right, code fast. I don't I have option. Oh, I have option over there. So code fast default. So this is the older ways to do that. This is the new ways you need to use the edge keyword. Edge means what? Right? Edge means he's talking about the access port. Non-edge means what? He's talking about the trunk port. Of course, right? Is the name suggests that non-edge. Edge means what? Edge means kinara, right? The last portion, right? So last portion is what? Access port. So if you see the switch one and we have a switch two, right? So we have a PCs over there, we have a PCs over there. So this 0/2 and this 0/2 will become the what? This 2 will become the edge. And this 0/0 and this 0/0 will become what? Non-edge. So you are going to enable the spanning tree port fast default, or we can say the edge PPT card default on the access port only. The edge keyboard is just saying that, hey, this feature is for the access port. So the in a like a Cisco packet, so you can go with this command. But again, of course, in the real world, if I talk about the real devices, you need to use the this command on the newer iOS version, not the older one. So this is the way that you can enable the global configuration. Okay, but edge ports can also have a trunk. No, edge port can also have a trunk. What do you mean by can also have a trunk? You know, make a trunk that access port cannot. Okay, you are saying that the edge port can become a trunk or not? Yeah, it can become a trunk in some scenario, but that should not be access. But on that one, you're not going to enable the port fast feature, right? Not the BPD guard. Because eventually what happen if they will receive the BPD on that particular interface, they will go in the error disable, right? Right. So that's all about the spanning tree guard. Second features that we have apart from the spanning tree guard, because in the spanning, if you see, I'm not saying the problem. Okay, understand this concept, guys. It's a very important one. I'm not saying that it is a problem or it is a bad about the spanning tree or BPD guard features. It's not a bad, right? if you see, if they will receive the BPDU, they will just put the port into the error disable state, right? And I don't feel it. It's a bad thing. It's a good thing. Because eventually what I want, so that attacker cannot join my STP network. That's I want from the BPDU guard. And that's a good part, right? But alternative solution that's something, it's an alternative solution, not the options we have. We have alternative solution is what? We have a spanning tree BPDU filter. Have a look the name over there, guard and filter. There's a word is guard over there. And second name is a filter. Guys, in networking, everything is depend on the name. If you understand the meaning of name, almost you are done with the 50% of understanding of any topic. Guard means a person will be sitting over there. They will block it. If they receive the any BPDU on that particular interface, they will block it. Filter. I'm just gonna filter the BPDU. I'm just gonna filter the BPDU. I don't have any issue with the error disable or nothing. I'm just gonna filter out the BPDU. So take example, if I'm gonna put the command switch 1, have a look over there, right? Same concept, right? If the PC is the 0/2, I'm gonna enable the BPDU filter over there. In that case, what happened? In that case, if the attacker comes over there and they will put the own PC right over there, and if this guy is gonna generate the any BPDU to this interface, then what happened? What 0/2 will do that? Said, hey, that's fine. I don't have any issue. I'm just gonna filter out the BPDU. I'm just gonna filter. I'm not gonna accept this BPDU. I'm just gonna filter out the BPDU. I'm not gonna accept this BPDU. So in the BPDU filter, what happened? Neither I can send the BPDU, neither I can receive the BPDU. So what happened? How about the attacks? Will there be attack in my network? See, if I talk about the spanning tree perspective, no. But if I talk about the beyond the spanning tree perspective, like any data traffic, they can do the DDoS attack in your network. They can do the DDoS attack in your, because this port is still not going in the error disable state, right? This port is not gonna go in the error disable state. It will still will be a forwarding state. Only the thing is what I'm not gonna accept and send the BPDU over there. I'm not gonna send, not gonna accept the BPDU over there. But the problem is what? STP is a different thing. But still I can send my data. Guys, please pay attention. STP is a different thing. STP packets, right? Your BPDU packet is your control plane packet. Right? It's a different packet. Data packet that you have, that's your ICMP packet. That's called a data plane packet. It's a different thing as well. So I'm just gonna, with the help of BPDU filter, what I'm doing that, with the help of BPDU filter, I'm just gonna blocking this guy. Matlab, I'm just gonna filtering out this particular packet. I'm just filtering out this particular packet. But I'm not filtering out this one, ICMP. ICMP still can go. So do you think that the BPDU filter is more secure than the BPDU guard? No. BPDU guard is a more secure, right, than the BPDU filter. Then again, question comes in the picture, where I can use the BPDU filter. Guys, give me 1 minute. I'm just getting the urgent call. Okay, I'm so sorry. My bad. So now the question is that why we have introduced the BPDU filter now? What's the reason behind it? See, what people are thinking about the BPDU filter. BPDU filter is the alternative of the BPDU guard. It's not like that. BPDU filter, it's not a pure alternative of the BPDU guard. Do you see the any alternative of it's a totally different thing. Can you see that? BPDU guard is preventing my network. It's not preventing my network. So the reason to introduce the BPD filter is what? To just, guys, please pay attention on what? To just segregate the STP domain. How? Let me give you the one scenario. What I told you with the BPD filter is just gonna filter out the BPD packets, right? It's just gonna filter out the BPD packets with the help of BPD filter. Now, please pay attention. Guys, give me one and let me put the one remind me. It's very important. Guys, give me 1 minute. I'm done almost. 50 p.m. Okay. Yeah. So now why we have introduced the BPD filter now? Have a look. Take example, we have a switch 1 right now. Okay. And we have a switch 2. And we have a switch 3. So I have a multiple scenario, right? But that scenario is a very high level. I'm just giving you the scenario that you can understand right now. Okay. So I have a switch 1, switch 2. This is my road bridge. This is my non-road bridge. And this is my non-road bridge. Try to understand, these are my all stable networks. So I have a user sitting behind the switch 1. I have a user sitting behind the switch 2. I have a user sitting behind the switch 3 as well. There is no issue, right? But somehow, these are, we can call it, this is the building number. Guys, please pay attention with the BPD filter, the use case. This is the building number 1, right? In another building, right? In the building number 2, right? In a building number 2, it's a very small building. I have a few guest user, I can call it. Sometimes some people comes in your company for the 10 days and 5 days, right? That's called as a guest user. So I have a almost, 100 plus guest user. Can you imagine 100 plus PCs we have? So I need to provide the connectivity to the all the 100 plus PC. So in that case, what do you have to do that? Because eventually this switches has a connectivity with the distribution layer routers. Then we have another router. Then we have a ISPs over there. So I need to connect this switch, right? Because on this switch, we have a 100 plus 4 PC, right? 100 plus PC we have. I need to provide the connectivity to the 100 plus PC. And this is just for the 5 to 6 days. That's fine. Because these are my guest user, right? What I can do that over there? If I'm directly going to connect the switch 4 to the switch 3, if I'm directly going to connect with the switch 4 to the switch 3, then switch 4 will participate into what? The switch 4 will participate into the spanning tree protocol. It means that if this guy has a by chance, if this guy has a priority 0, then what happened? Your complete path, your complete root port, DP port, everything will be changed over there. Understood? Your root port and DP port, everything will be changed over there. And somehow if this guy is a priority 0, then it will become the root bridge and it will go in the non-root bridge. And forget the priority, make sure that, like, let's take example. I will make sure that this guy should not be have a priority 0. This guy should be a priority will be high always. So it will also always become the non-bridge, but still what happened? The election of this segment will be happen for the root port and the designated port. So if the election will happen on the root port or designated port on this particular segment, then what happened? It will impact to the this segment as well as this segment as well as. If it's going to impact to the this segment, then it will impact to the this segment and this segment as well as this segment. So eventually entire switches, right, entire network will be impacted if I'm just going to add the one switch. So for example, you can say, hey, law, that's not a big deal. Because that's fine, right? I can get the connectivity with those 100 plus PC, right? I have internet on the 100 plus PC. Dude, understand, for the CCNA engineers, that's fine. CCNP engineer, that's fine. But if you are at the architect label, right, if you are at the CCI label, then you need to think not about the only the internet connectivity perspective, you need to think all perspective, the CPU perspective, the memory perspective, the down, packet drop perspective. If I'm going to make a connectivity over there, then what happened? If the complete network is going to change the RPDP, then TCN will be generated. My MAC address aging time will be like a MAC address will be flooded. For the few minutes, what happened? You will not have any data traffic. So to avoid all this set problems, what I can do that? I can just enable the BPD filter, man. I'm just gonna enable the BPD filter. Neither I can receive it, neither I can send the BPD. If I'm not gonna send it, I'm not gonna receive it. I'm not gonna participate into the what spanning tree domain, but still I can get the internet to the all the 100 plus PC. Again, this is the one of the basic example that I gave you. But the major use case of the BPD filter is comes over here in the layer 2 VPN as well. That's a very high topic. CSI service provider. Guys, anyone has a questions? All good?
The BPEDU filter is enabled in both end or
It's
any
fine.
one
Even
end
if
is
you enable on the one side, it's fine. That's fine, or not an issue.
okay.
So make sure that you have to enable on this guy so that he will not send and receive it. So how you can do that? You can simply go a simple command is there. Let me show you that. Let me do one thing. Let me let's have a look over there. I can do that. If you see on the switch to this particular interface, so in spanning tree interface 0/1 detail. Sent 69 71. Let me enable the filter. And so I'm not sending it. Okay. I'm not sending it now. All good. So you have to enable on which particular switch? On this particular switch. If you enable on the both the side, that's all fine. There is no issue. So in this case, I will not send it, not receive it. He will also not send it, not receive it. So I can save the bandwidth of. See, if you think about the higher level perspective, you have to do on the both side, right? Save the bandwidth. But again, it's up to you, man, up to your scenario, like how you are using the BPD filter. So normally, if I talk about in the production network perspective, like, normally I have seen the BPD filter is enabled on the layer 2 VPN side that I gave you the one example, right? Layer 2 VPN mostly. And BPD guard is normally used in the production side. Okay, why this switch goes down? What happened to this guy? Okay, so next part, what we have now. Let's call as a. Okay, one thing, you can, on this particular interface 0/0, you can enable the BPD guard and BPD filter at the same time. There's no issue. But this is your task for you, right? The task is what? You need to find which will take the preference. If both will be enabled on the one interface, which one enable to first? Okay, I just seen your message. Okay, I'm telling you, I'm just giving the question. Same question, right? So for, you can enable anything BPD guard, BPD filter, that's not a fine. And you can enable on the both the interface, right? On a one interface, you can enable both the things, but anyone will take the precedence, right? Now the question is which one? So that's your task. You need to find which one will take the precedence if I'm gonna enable the both the thing on a one interface.
The guard.
And why?
Because the filter is just filtering, but the guard is actually preventing. So, in
पक्का?
हाँ पक्का 100 टका पक्का.
ठीक है, कल देखते हैं इसको तो. Okay, so next we have, so that's called as a loop guard. That's an interesting feature, right? So normally what happened, take example, we have a switch 1, we have a switch 2, we have a switch 3, and here we go, 0/0, 0/0, just a second. We have 0/0, 0/1, we have 0/0, 0/1. What I told you that, if you guys remember that, in normally DP port is gonna send the BPD packet, RP port is gonna receive the BPD packet, DP port is gonna send the BPD packet, and blocking port is gonna receive it. So normally what happened, the BPD will be traveled like this, but DP port is gonna send the BPD packet to the RP port, RP port will receive it, and from the DP port is gonna send the BPD packet to the blocking port. So here's the blocking we have, right? So on the blocking port, we can only receive the BPD, right? I'm talking about the configuration BPD perspective, guys, not the TCN. TCN you can generate by the RP as well. That's not a big deal. And the DP port is gonna send the BPD, and we can call it the RP port. You can again receive the BPD. Now what happened? Your one interface 0/0. We have a two things over there. One is called the TX means transmit, right? So your one interface is divided into the two components. One is called the TX component, one is called the RX component. RX means what? Receiving it. So understand this concept. Yesterday I gave you the example of what? Max age time, which is by default what? 20 seconds, if you guys remember that. So let's take example. The major role of the block port is what? I'm only gonna receive the BPD. That's a major perspective. I'm only gonna receive the BPD. Right? What happened? What happened? Right? If this port, right, on the 0/1, we have two things. One is called the TX, one is called the RX. If TX fail, that's fine. It's possible. Nowadays, it's possible. TX fail. If the TX fail, then what happened? Can I transmit the BPD now? No, I cannot transmit the BPD. My TX fail, right? If my TX fail, right, I can only RX is accepted, right? My TX has failed. I cannot transmit the BPD. So if I cannot transmit the BPD, then what happened? This interface will wait for how many seconds? This interface will wait for the 20 seconds. Remember yesterday we have seen that? Till the max is time. Then what happened? After the 20 second, my port will be moving the listening. 15 second, then we have a learning, 15 second. Total is what? 50 second, right? In 50 second, what happened? This port will be moving the forwarding state. Now try to understand what happened. If this port will be moving the forwarding state, already this port was a DP port, right? Already this port was a DP port, and somehow if this guy will become that also DP or RP, then what happened? Do you have any blocking port over there in this network now? All DPRP, all DPRP, and all DPRP. There's no blocking port loop comes in the picture. And why this thing is happening? This just happened because of the loss of BPD. This just happened because of the loss of BPD. Yes. Just give me a minute. Can you hear me now? Yeah. So this happened just because of the loss of BPD, right? Loss of BPD in the sense of what? I'm not able to send the BPD. That's called the loss of BPD, right? I'm not able to send the BPD because of my TX fail. I'm not able to send the BPD. If I'm not able to send the BPD, how many BPD? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. After the 10, what happened? My max's time, that's a 20 second, will be expired, right? On this particular port. Listening, learning 50 seconds. Now all the ports are the forwarding state right now. Problem. In this case, what happened? Loop will be there. So let me show you this example in the over here. So I cannot down the, I cannot down the TX over there. I'm gonna use the BPD filter to show you this behavior. So I have a switch to right now. Let me show you that. So you can see that so span tree right now. I have a root port over there. This is my DP. Blocking. And with the help of a span tree filter, what caused the TX field? Any hardware issue, Bhujan. It's a hardware interface. It's a hardware issue.
Thank you.
So let's have a look over there. So normally it has to be send the BPD if you see that. So spanning tree interface E0/1 detail. If you see that on this particular interface, I'm keep sending the BPD. Can you see that? Sent 236, 239, and then 241. So I keep sending it at every 2 seconds. What the switch 3, this interface 0/3. It will say that, hey, I'm gonna keep receiving it. That's my behavior. So spanning tree interface E0/0 detail. Oh, come on. I'm keep receiving it. See that? I'm not sending it. I'm just receiving it. 34, 35, 36, right? I'm just receiving it. I'm not sending it. So my behavior is receiving it. Your behavior is sending it. But what happens if your TX is down? How? Let's have a look. Interface 0/1. I say that spanning tree BPD filter. Enable. It's gone, man. So I'm not sending it now. Can you see that? 266. Done. Not sending it. How about this guy now? Just 3. If you see, I'm not able to receive it now. 746. Still 746. Behavior, if you see that, my port has moved in the listening state now. Previously, it was in the blocking. Can you see that? Now it's going in the listening state. Then it will go in the learning now. This interface is moving in the learning now. And few minutes after the few seconds, it will jump to the forwarding state. And if it will jump to the forwarding state, what happened? Go, man. DP port. Can you believe that now? Is it possible in normal scenario? See, there is a memory issue comes in the picture. My SOS2 goes down. So yeah, the loop has done. I had some issue with the SOS2. My SOS2 goes down because of the memory allocation has failed. So all are DPRP or DPRP, right? And this has just happened because of the loss of BPD. Loss of BPD means what? Just for the, see, one is the TX issues comes in the picture. Another issue I'll give you. Take example what happened in sometimes, if your link is get congested. Congested matlab kya hota hai? Congested, right? Congested means what? Something that cannot travel properly. Something that cannot put properly, right? So take example, if the link is too busy, and he's not able to send the BPD packet to this guy, right? For the 20 second or maybe 30 second, then again, what happened? Loop will be there. Then again, right, this blocking put will move in the listening learning. So two things will happen, either the loss of BPD, the loss of BPD will happen, could be any reason, because of the hardware failure of the TX, and second is the congestion, right? So to avoid this problem, what I can do that? I can enable the loop guard feature. So loop guard feature, you are always going to enable over here. So on this particular interface, I'm going to enable the blocking port. I'm going to enable the loop guard feature. On the blocking port, I'm going to enable the loop guard feature. And what this guard is going to do that, man? Loop guard. Loop matlab what? I'm just going to detect the loop. If there is a loop, I will prevent this interface to becoming a loop. I will just put this port into the loop inconsistent state. If I'm not able to receive the BPDU, because my aim is what? I have to keep receiving the BPDU. But if I'm not receiving the BPDU, right, I will wait for some second and then I will put this port into the loop inconsistent state with the help of loop guard feature. So if I'm going to put this port in the loop inconsistent state, what happened then? Still this guy will be a DP. This port will never move in the listening and learning and not even the forwarding. It will jump to the loop inconsistent. So to just prevent the loop, or we can say that to prevent the loss of BPDU, right? We can enable this feature loop guard. How? Very simple one. Let me go in the 0/0. Spanning tree guard loop. Right? Now let's go on this guy. If you see, I'm keep receiving it now. I'm not sending it, but I'm receiving it. Let's go on the switch 2 now. On the switch 2, what I can do that. So yeah, switch 2. I'm just going to enable the filter again. If I'm going to enable the filter, and if the switch 3 on the blocking port, if I'm not able to receive the BPDU from the switch 2, I will move this port into the loop inconsistent state. Done. 814 is still 814. 811. Wait for some time. I'm still in the alternate blocking. Wait for the 20 seconds. That's a max is time. And now all goes done now. I'm putting this port into the alternate blocking. It's called as a loop guard block. If you see, it's called as a loop inconsistent state. Sometimes this port is called as a broken port. We can short term is called as a BKN port. Very important interview questions, guys. Sometimes people are asking, hey, what is this port called now? So if you see the source spine tree, it will show you the BKN now. BKN means what? Just for the temporary, the port is in the blocking state right now, because I cannot send any kind of data traffic because of the loop inconsistent. All good? So if I'm going to remove the switch 2, if you go on the switch 2 again, and if I'm going to remove the BPDU filter, take example, if my link is working fine, everything is working fine now, my conjunction has removed, my TX is working fine, it comes in the normal behavior automatically. Wait for some time. Automatically what happened? It comes to the normal behavior. Come on. I just remove it, right? I'm sending it. Okay, let me shut down. So normally it has to do the automatically. I don't know why it's not doing that. It's not in our behavior now. So this is called as a what? Loop guard feature. The fourth one that you can use it, what? It's called as a root guard. So take example. Again, loop guard feature you need to enable on the per interface basis. There is no global configuration command. And you're going to enable on the blocking port. On the blocking port, you're going to enable the loop guard. The fourth one is what? It's called the root guard. Root guard. Name suggests that root guard. It's going to prevent the root bridge. Provide the protection, not the prevent. Provide protection to the root bridge. How? Switch 1, switch 2. And that's fine, right? I have a multiple switches in behind this guy. That's fine, right? There's no issue. Multiple switches. Switch 1 is a root bridge. This is the DP port and this is the RP port. Take example, what happened? If there is an attacker behind this guy, right? It is the attacker, right? This attacker will send the BPDU with the priority 0. This guy will send the BPDU to this guy with the priority 0. When the switch 2 will send the BPDU to this guy with the priority 0, then what happened? Then the switch 1 said, okay, your priority is 0. You will become a root bridge. I'm not a non-root, now the non-root bridge. Because he has advertised the BPDU with the priority 0. So in your network, right? In your network, not only the attacker, any other switches, right? Any other switches can generate the BPDU packet with the priority 0 by mistakenly, maybe, right? Maybe by mistakenly, or maybe the other switches has a lower MAC address. Anything is fine, because if the priority get tied, if the other switches, right? Because you cannot change the MAC address, right? And you have no idea which MAC address has a which switch. So by default, if the other switches have a lower MAC address than the switch 1, then the other switch will become the what? Root bridge. Now you may have a question, hey Law, that's not a big deal. Because that's my own switch. If my own switch will become the root bridge, I have no issue. But dude, try to understand, if the other stick example, if this switch will become the root bridge, then what happened? Your complete layer 2 network will be changed. DPRP will be changed. Your MAC address table will be flap. Your MAC address table will be changed now. Everything will be changed. So for the few minutes, what happened? Your network will become the unstable network. And in an unstable network, you cannot send your data traffic properly. So to avoid this problem, what you can do that you can enable the root guard feature. So what root guard feature is gonna do that over there? So if any other person is gonna send the packet with the lower priority, or we can say the better priority, and it doesn't matter what priority I have. Even if I have a 32768, right? That's a default priority plus VLAN number 1. And if somebody is sending the priority 0 on this particular interface, and if this particular interface is enabled with the root guard, immediately this guy comes in the picture and say that, hey, listen, I'm there right now. Your port, this port will move in the root inconsistent state. Why? To just prevent my root bridge. To just provide the protection to the root bridge. So if I'm receiving any BPDU, or we can call as a superior BPDU. Superior BPDU is what? Better BPDU. If I'm receiving any better BPDU on this particular interface, if the root guard is present, he will say that, hey, listen to me. I'm there right now. Now I'm moving this port into the root inconsistent state, right? Because my job is what? To protect my root bridge. Doesn't matter what priority they have. So simple command. So have a look. I don't even need a switch 3 right now. So of course the switch 1 will become the root bridge because of the lower MAC address, right? So have a look. Right? So what happened in the switch 2? Let me show you the default behavior right now, normal behavior. If I'm going to go in the switch 2 right now, instead of host name switch 2 and host name switch 1, have a look. If I just go to the switch 2 and say, hey, spanning tree, VLAN number 1 priority 0, fine. Now I'm the king, right? So I will be king now, and you will be the non-root bridge. See, no issue. There's no any protection in my network. That's fine if you have 2 switches, but take example, if you have 100 plus switches, right, a big layer network, then do so spanning tree. See, I'm the root bridge now. Understood? That's a problem. So let me remove this guy again back, and let's make the switch 1 as a root bridge. Come on. Man. Now, that's fine. Now it's become. So now he's a root bridge right now. Back it. What I can do that, I'm going to enable the root guard feature on this particular interface. So let me enable the first this guy. Interface 0/0, spanning tree, guard, root. That's done. So a spanning tree, interface 0/0, detail. This guy has a lower MAC address 0/100, but the priority is the same right now. 32768 is the default priority plus VLAN number 1. What happened if the switch 2 is going to say that, hey, let me change my priority because I want to make an attack in my network. Priority 0. If I'm going to say this guy, what happened? Have a look. He will send the BPD packet with the superior BPD with a 0 priority, right? Switch 1 said, hey, doesn't matter what's your priority. My behavior is to block your port. So this interface has moved in the which interface, which one? The root inconsistent state scan as a broken port. What as a broken port. So if I'm going to remove this guy, it comes to the default behavior. Wait, it will come. You see that? It will take some time, but it will unblock this port now. So now it's normal behavior. So now he's not sending the any higher priority, now priority is same. Previously it was sending the 0 priority. I was putting this port into the root inconsistent state. But now everything is normal. That's fine. I don't have an issue. So that's all about your guys' spanning tree security. The port fast, BPD guard, BPD filter, root guard, loop guard. Questions? Again, this all the technologies that you are going to implement in your network based on the requirement. Okay, I gave you the example of the BPD filter and the guard. Both are in a different situation, not in the same. Go ahead, questions.
So, so the BPD, sorry, the spanning tree is finished or still is running?
No, we have.
Because I missed the yesterday class, so I was
I
just
know.
wondering.
No. We just have done with the PVST protocol, man. We have done with the PVST. Now we'll jump to the what do we call RSTP and MSTP.
Okay, I see.
See, anyways, there's a lot of if I'm gonna take the spanning tree protocol, I still have almost 15 hours of the content to take the spanning tree protocol. But that's not
Yeah.
gonna make a sense, right? Because that's again gonna consume all the 15 hours only for the spanning tree. Remaining topic will be pending, right? So this class will go on
No,
the
no,
next
that's
5 to
fine.
6 months.
Obviously,
Yeah.
our level is not that higher.
Right, that's right. Yeah.
Makes sense. No problem. So that's it for today, I think.
Yeah, that's it for the today, man. Anyone has a
Okay.
questions?
So this lab can we do on packet tracer, isn't it? The yesterday lab and today lab.
Yeah, loop card, root card, you can do that. And sorry, loop card and root card you cannot do on the packet tracer, but remaining you can do that. During the root consistent. Of course, not Nisar, never. It's a broken port, man.
Hello,
Yep.
Sir Vijay.
Yeah, Vijay, I can hear and see that. Yeah, tell me.
Sir, today morning.
अच्छा
I
तुम
have
ही
a
ने कॉल किया
question.
था क्या यार हुआ क्या तुम्हारा सॉल्व
हाँ sir.
क्या था इशू
No sir.
सॉल्व नहीं हुआ यार
नहीं sir.
एक तो पता है क्या